Hi guys, a little project's coming to do, high paying job. It's for my son, so look up there, that ain't going to happen, is it? Right, my son had a Volkswagen Golf GTI with air ride suspension that he'd fitted, big compressor in boot, fancy suspension, he could dump it, make it go up and down and all sorts, because that's what he does. But when he come to sell that car, he realised that he'd never get the money back for the cost of this suspension. So he removed it and put standard suspension back on again. So he's got this air ride and he's now got, I'll show a picture of it, probably up here somewhere, I don't know, wherever, or maybe a full-size picture of a little video of a Skoda Felica Fun, which, if none of you know what one of them is, it's a Skoda pickup, same as a Volkswagen Caddy, but really old, very old. It's absolutely rotten. He's got tons of welding to do on it, so he's just learning to MIG weld. We've got him set up, and he wants to put this air ride on it. So I'll take it over to the bench and I'll show you the air ride. I don't know if you can just see the leg there. We're going to attack the front first. Basically, the leg is fatter than the hole at the back of the suspension where the leg fits in, the McPherson strut shock absorber fits. And I'm going to make a reducer, but the humidifier is making a funny noise. I think it's that. So I've got to make a reducing collar and the leg isn't long enough. I'll sit them side by side because I've got the one off his car and I've got one of these fancy units, and I'll show you them and then you can see what I'm going to do. Okay guys, just thought I'd introduce it. There'll be a bit of video goes in showing his air ride, how it worked on his Golf. I've got a few clips of that and a little walk around of his Skoda that he's got. So this is his setup. This is the original suspension leg from his car. You can see all that to its end. I'll push it bench a little bit. It's this end here is what fits into the socket that's in the casting at the back of the hub. Spring and shock absorber. As you can see, length for length, that this one's much shorter. This is like 115mm longer, but that don't matter because the car sat very high and he wants to lower it before the air ride even works. With it collapsed, it'll be, as you'll probably see in his golf pictures. So this is the leg. Now this is your airline that pumps it up and down, and these are two airbags, 1, 2, which I should imagine is a similar sort of setup, what's like on a Range Rover, etc. And it's got a fancy collar at end, all adjustable for your camber. It is fitted with 2 bolts, this one's 3, so he's going to have to modify it top leg anyway, the top cup. And it's an adjustable leg, so you can crack that nut if you can ever crack it. I bet it's C solid. And you can wind this up and down, so I think there's quite a lot of length in here. So he can get some more stroke on it if he needs it. I take it that's for brake pipe. So this socket here, as you see, it's just open at the end. So I've got to make a sleeve, because that diameter is 50 some. And this is 40 some, so that won't fit into his suspension anyway, and the leg is too short. So what are we doing? Let's see if I can find a bit of room. So I ordered a piece of metal. We knew we wanted 115mm in length, and I know that this is 55, so we decided to give it a 5mm strength on the side of the leg, so it'd be nice and beefy. That's not 5, that's about 3, is that? So it's going to be stronger anyway, and that's going to sit on there. I'm going to drill and fit 3 grub screws so it don't fall off if he jacks car up. And then I've got to reduce the end of it down, the last 43mm of it, down to this diameter, which I believe is 43mm, but I'll check all that. And so this is a piece of steel I got, and I've just unpacked it actually just before I started this camera going. If you can see that, what a lovely piece of steel. Lovely chunk. So I'm going to have to get bandsaw going. It's mild steel, but what grade of mild steel? It's definitely mild steel. I nearly started thinking it was stainless. Right, so that's 250mm long. It's 65mm, if you can see that, I don't know. It's 65mm diameter by 250, and it says on it SCG, right, and BDMS. So mild steel, BD. I don't know, because I don't know steels, but we're going to do it. Now, I've got to chop that in half. Well, I've got to chop 115mm off, then another 115, there'll be a little slug left. And the plan is to do this in Myford. I'm going to have to do a lot of boring to get through, to make it fit this leg. And I'll probably relieve inside of the reduced end as well, just so it ain't too heavy, because that is very heavy. I don't want too much weight on this suspension. So that's my project. That'll be a freebie. It's paid me for this steel already. That piece of steel was £39.70 something, I believe. 40 quid delivered from eBay, from a steel supplier. It did take quite a long time to go. It says next day delivery, but it obviously didn't get to depot very quick because it took well over a week to come, but we've got it anyway. So I'll add bits to this video as we progress along the way. Obviously I've got to get this in Myford. My worry is the weight of it. I've obviously chopped in half, it's only half the weight, but I've got to get that in Myford and bore it, and obviously because I'm going to bore it, I can't put a centre in to steady it, which is a worry, because the headstock isn't that strong on them. I really could do with you know, a travelling steady in it, but I haven't got one. It was something I always thought about making, but never did. So yeah, let's lift up a bit. So that's what we're doing. Have a quick drink. And as it progresses, I'll show what I'm doing. It's not a big project, is it? Not like what Matty's just done. Matty's workshop. Any of you follow Matty? Wow, he's just made that winch. I don't know where he's going to use it, but I'm assuming it's for in his garage. But what a beautiful job he's made of it. Absolutely stunning. Some lovely stuff. And he shows up what you can make balls of cotton of. He cut his own gears, and I don't think he's done it before with an indexing dial. It frightened me to death doing that. I've got a load of gear cutters, and I've got some arbors for them as well, but I've never used them. But he cocked up a couple of times, and had to remake them, and it was quite a big piece of steel, probably something like this. So I bet it's cost him a bob or two. But bless him, he showed it, which is brilliant, Matty. That's what we need to do. If you make a mess, let me show it. People say, oh, you shouldn't show stuff like that on YouTube. Of course you should. You make a mess, show it. We all make mistakes. We're not machines, are we? Okay, guys, rattled on enough. We'll progress. Yeah. Forge jaw. Best way I can grab it, and I ain't got a steady rest. I can put a centre in to turn this 43mm bit or 44mm bit down, but then I'm boring it, so I don't know. I ain't got a steady rest. Really need one. If I start boring that with boring tool, it's probably going to come out. To really have a think about that. It's either that, or I somehow put it in milling machine and use that boring cutter I've got, that adjustable one. That bit on it other way. I'd prefer to do it in lathe if I could. Okay. clean up time, I think. Right, so that's down to size. I've put a chamfer on there, so that sits into the original suspension casting. I've taken the centre out, and I've now got to bore this. So I'm going to leave 5mm. I'm going to bore it to within 5mm, and I'll go to a depth of just past there, just past here, because the other side of that's going to be bored out anyway, much bigger. But I don't want to take it out of the chuck until I've done all the work from this end. Hour side, right, taking 30th hour off the bore. I'm nearly to size actually. There is no size given, it's just I'm just trying to get some metal off it to lighten it. Actually, I'll show you this. Get it back up to speed. Yeah, it's flickering because of the camera frame rate, but it's 487 and we're running on inverter 36.1 hertz and we're on the top pulley. Oh, I never moved it back. I don't know why. I meant to put that back onto the middle one, or next one down, should I say. But we're okay. I'll keep away from the chuck. As you can see, them jaws are stuck out a long way. I think that'll just about do for that. It's rough as hell, but it doesn't matter. There's no point in making it smooth and nice because it's never seen it. It's just what goes in suspension. I think that'll do. My next question, what do I do? Let me get this other bit of bar. So I've got this other piece of bar cut. That's what we're left. Oh, right. I did find out what that was. And that SCG is something to do with using it for the grade is something to do with reinforcing, which is a bit weird. But other one is bright, oh come on, bright drawn mild steel, it stands for. So this next chunk of steel, do I carefully undo 2 jaws and remove that because it's set up, and put my other piece in and do this work? Or do I turn that round now and close these up and finish it? Personally, I think I ought to take the next one and make it the same as that, and then the finished job, that'll be the same. Once that's set up, it'll be the same for the other one. It'll save time, I think. I think that's the way to go. As I say, I've drilled a hole all the way through anyway, so I can pick up my centre from other side. But if I just gently unnip that and that, I can remove that and do my other piece, nip them back up, do a GTI check, and I think that's got to be the better way. Otherwise, I'm going to have to reset the GTI up and do, you know. It took me 20 minutes to get this right. I know these guys, you watch them on YouTube and they seem to do it in about a minute, but I can't. To get it absolutely well, I got it within 0.02 of a millimetre, which is near enough for what I wanted to do. Okay guys, so this bit's done on my mobile phone, not on the trusty camera. So there'll be a mix and match here. I hope it all matches okay with the resolution, etc. It should do. Some of that's accounting for little burrs and bumps in here. There's a few marks on it and it's making needle jump, but that's pretty accurate at that. Pretty good. So we're all ready to go. It's all tightened up and we're all ready to go for the next cut. This is the one I sharpened yesterday, if you can see it, but probably not. I backed it off on the back of the floats. A lot of people, when they're doing these by hand, they end up chamfering it too far back and it makes it dig in. It only needs to be a few degrees back as the cut. Right, just thought I'd show that. So 180 RPM, running real slow. And once I've got this though, I can get my boring bar in. Ten-thousandth of an inch equals an overall bore expansion of 20, both sides obviously. So for you guys, hang on, I'll just get a drink. You guys that are going to watch this that haven't got a lathe, I'm just trying to show the operation and what I'm actually doing, because quite a lot when you see on YouTube somebody making something and you know you just see, oh that's hot, I need to let that cool down a bit, that's why it's probably squeaking. You see somebody doing it, and if your camera's close up, which I usually do have a close up with my camera, you can't see the operation. And I'll go through the operation with you. Let's just make sure you can see it all. Yeah, I think you can see everything that you need to. So, first of all, to make this lead screw active, it goes through this gearbox, and this lever here, and I showed earlier a video of inside here, you've got a pair of Tufnell gears, all the rest is steel, but they're Tufnell so that they can break. Excuse me, I suppose it's your sacrificial gears if anything jammed up. So if you run it like that, that's just the lathe running, and all you've got is the main spindle going round and that system there operating. None of this is working. I hope you can see that, but none of those gears are going round. That's all static. So all that system in there is purely to drive this gearbox. Tension that way. Comes in a little bit. They say this is not for guys that have got lathes, but for them that haven't, and they're wondering how it all works. So all those gears in there, I'll activate it, and then you can see. Oh, this is a. Can you see that lever? No, you can't. That's a clutch. I'll lift the clutch so I don't have to turn the engine off or the motor off. I'll close that up. Well, don't have to close it, leave it open. If I want this lead screw to go so the carriage cuts that way, I put the lever down. If I want to drive the carriage the other way, I'd put the lever up. So for instance, in that position there, now all that gearbox is going round, as you can see. see that's going to the right now, away from the work. So if you were going to put a piece of metal that way, you'd have that lever in work position. Okay. If you want it to come towards the work, then you put it in that position, which is down. Okay. So then what you saw me doing is using, let's zoom out a little bit more. So using this incremental scale on here, which is in thousandths of an inch because it's an imperial lathe, I can set how many thousandths of an inch I want the cross slide to go in that direction. Well, in this case, because I'm cutting this side, I want it to come towards me, so I'm going backwards on here 10 thou at a time, which gives an overall cut of 20 thou. This lever engages it, and this, you'll see, follows it, which is just your hand wheel if you want to do it by hand. How does that work? So you'll notice when gearbox is running, and the speed of that shaft depends on where you put these gears. So let's let you have a look at those gears. They're a marvellous gearbox. I don't know whether they were made by Myford or Triumph or Norton or whoever, I don't know. If I can get it to come back into focus. Maybe that is. So all these numbers on here, they all correspond to speeds for screw cutting. This lever here lifts up and down, you pull a plunger, move it up and down, and that can be moved along from anywhere between 1 and 8. And it tells you on here what the speeds are with the lever in which position. There's 3 positions of the lever, left, middle or right. And that it's all you do is read what you want, the speed. So if I wanted 24, I would have my lever to the left, which it is, sorry, I'd have it in the centre, and I'd have it on 6, because that's 6. I've got it on 12, because my lever's to the left, and I'm on 6, so I'm cutting at 12 threads per inch. That's the speed that goes at, as if you were cutting a thread, 12 TPI. So, how does the half nuts work? This lever here, when you lift it up, there's a pair of threaded, it's a nut, pair of jaws, and they're threaded with that thread, which is an Acme thread. That's what it's called, square cut. And it's open there. And when you push that lever down, it closes like that, around that, and the thread then bites onto that, and this whole carriage travels with that screw, whichever way it's going. And that's how the half nuts work, and that's how the power feed works. It also has cross power feed that way, but I'm not using it at the moment. I'm just using that, so I'm not stood here winding the handle continually. Saves you a lot of work. A great addition if you've got a lathe that's got one, it's great. If you haven't got a lathe at all and you're considering buying one, I'd certainly look for power feed. It's very handy. Screw cutting gearbox, unless you pay a lot of money, you're not going to get one, because even some of these Myfords, they don't come with a screw cutting gearbox. You know, it's an extra as such. I was lucky I found this one with all the bits and bats on it. So, okay, I've digressed a bit, but I'm just trying to imagine who might watch this on YouTube, and I know there's a lot of guys that I know that probably watch it, and I watch them, and we give each other comments and stuff. Well, they all know this. I can't tell them how to suck eggs because they know all this. But a lot of people that are watching YouTube, maybe for the first time or watched it before, and you know, they'd probably just see something being cut and think, well, how to do that? Well, now you know. That's how I do it. I'm running inverter, so I'll tell you what speed we're running that at. I will slow that down as I get further out when the hole gets bigger, because it's the surface speed of the metal, and obviously the bigger the diameter, the faster that surface speed is, and it'll probably start screeching. $448 RPM and 33.2 hertz, 33.3 hertz, which we can alter the speed of that by just turning it up or down. And that's a 10-turn pot, so I can set that quite accurately. With a single turn pot, it's not that easy to adjust your frequency. And with that, I can turn it and turn it and turn it. You can see that. Right. So it's stopped. 0. Why is it being noisy? Because I've got all those gears running. Let's take it out. Be quiet. Right. It's quieter now. So if I want to run 300 RPM, I've got a much more accurate, by having a 10-turn pot, chance of getting 300 RPM. RPM equals 22.4 hertz on my inverter. You see how accurate you can be. You know, these lathes, they only come with the standard motor with those speeds there. They're your standard speeds with your standard belts, and by moving your belts around you get different speeds on there. I hope I've helped anybody that's considering buying themselves a lathe. I'm not telling you to buy a Myford lathe. They're lovely lathes, very old, but unfortunately they're very expensive as well. They command stupid prices. You might see odd one going cheap that's probably got problems with it, no gearbox and no power feed, but yeah, for something, I mean, they're still selling these now. I don't know whether they're still casting them or what, I don't know, but they're building them and selling them, and they're about £10,000. I mean, they're some nearly 9 grand plus that. They do it as a connoisseur, it's called now, but it's more or less the same as that. I think they're a long bed, they've got a slightly longer bed. But don't be put off one at Chinese ones and things like that if you're looking for a lathe. I mean, Warco do a nice one. I don't know if Sega do one. There's quite a lot, and I'm sure they're quite a capable lathe. I just fancied an old English one, English engineering, British engineering thing, you know. So that's cooled down a bit. Yeah, that's cooled down a bit now. I'll carry on cutting. I won't show any more of me cutting because it is laborious and I've a lot to do. And it is 10:30 at night. yet again, for the second time now, I've had to recenter this in the jaws. I do suspect them jaws are slightly flared, but it's moved twice and gone off centre. You'll have seen in one of the earlier videos it wobbling. So I've recentered it now. So we're back to within 0.01 of a mil. And I'm going to do it again, which, you know, begs me even more that I need a steady rest for around here. I've ordered one, so I'll be doing a YouTube video of that when I make it. It's if you remember, any of you guys that watch my channel, me making this Hemingway's, then you'll know the Hemingway's kits, and it's a Hemingway's one. The Myford one, and if you can get hold of one, they're not cheap, but the hole in them's quite small. I don't think that would have fit in a Myford one. So the one that Hemingway's kits do is for the Myford, so it's got the 3.5 inch centre, whatever it is, the centre height right. Because we're going to buy a second-hand one off eBay and machine the bottom of it till it fit, but it's all hit and miss. So I've ordered one from Hemingway's kits. It should come by Thursday, tomorrow, all being well. But I'll carry on with this until it's finished. But it's my next project is to build, and as you know, the Hemingway's kits come everything's there, but it's all just bar stock and castings, and you have to machine it all up. So it'd be an interesting little video to do, a bit like I did with the I'll try and do it quicker though, because it went over 8 parts, did that knurling tool, although there were a lot of bits in it, but it was too long. I'll make something shorter. Okay. We'll carry on boring. So that wants to be 2147 Imperial. Actually, 2144 without using bore gauges. 2144. So it's on a 3.3. I'm going to let that cool down because it'll shrink when you turning something. It gets hot like that, and it is hot because the swath's all blue. You got to let it cool down because you got quite a few thousandths of an inch of movement. So I'm going to let that cool down, take another measurement and just skim off what I need to, so it's a snug fit on this suspension leg, and then that's that one complete. The only thing left to do is, apart from deburring it and cleaning it up, is to put 3 grub screws in it, 1, 2, 3, sort of triangular, just to hold it to the leg so it don't fall off when he jacks car up. I'll see what I've got. I suppose M5's a bit best. I'll see what I've got, but there's plenty of meat on that metal to grip on. There should be technically about 5 mil left. Metric. 5.36. So yeah, by the time I've taken a bit more out of that centre, yeah, it's about 5 mil. That's cleaned out nicely. So I've cut that a speed of 400 and a bit RPM, and I've used the screw cutting speed of 6, leave it there, 12 TPI. Now for my final pass I ought to turn that screw cutting right in the gearbox right up to maybe 20 odd or 30 TPI, and then it'll go through much slower, and that'll be much smoother. It's not bad as it is, and to be honest with you, it's probably better like that because it'll grip on the leg better. But just for purposes of it looking nice when it's done, I'm guessing it wants to go through nice and steady. It's only going to want a few thou off now. As I say, when that cools. That's just hot to the hand. I can't keep my hand on that. So I'm going to let that cool for 10 minutes. Get it down to ambient, and then start with next one.